Okay, so now let's get into hypothesis testing. Okay, what is a hypothesis test? A hypothesis test is just trying to tell us whether or not it is reasonable to believe a certain suspicion or a hunch. Okay, now I mentioned before when it comes to a one sample hypothesis test, what we are doing is we're trying to determine if it's reasonable to believe a suspicion or a hypothesis about our population and a specific value. In other words, is it reasonable to think that it will take 5.5 hours or less to fly to Los Angeles? Is it reasonable to think that Home Depot's stock price will be $75 or more? Is it reasonable to think that we have invented a lithium ion battery that can charge in exactly 2 minutes? Okay. Those are all examples of things we can do with a one sample hypothesis test because we are trying to look at the relationship between a hypothesis, a hunch, and a specific value. Okay. Now, I want to be very clear. At the end of the day, all hypothesis tests, all hypothesis tests are nothing more than comparing a test statistic against a critical value. Okay. A test statistic versus a critical value. The test statistic is sort of, the good guy. It's the good number. You're going to calculate these. Okay. The critical value is a second number, a different number that separates the good area, the good region from a region of rejection. Okay. And I'm going to draw this on the whiteboard in a minute. Okay? If your test statistic crosses the critical value, if the test statistic crosses the critical value and lands in the region of rejection, if it lands in this bad region, this rejection region, then what you are going to do is reject your hypothesis. You're going to say, nope, my hypothesis is wrong. Nope. Home Depot stock price will not be $75 or more. No, we did not invent a lithium ion battery that charges in exactly 2 minutes. Okay. You'll reject your hypothesis if your test statistic falls into the region of rejection. On the other hand, if your test statistic does not cross the critical value, okay, if it doesn't go past the critical value, and if it ends up in the good region or the region of non-rejection, then what you will do, what you say you've done is, hey, all right, my test statistic is in the region of non-rejection or the not rejection region, the region of non-rejection. Therefore, I fail to reject the null hypothesis. Okay. If you fail to reject the null hypothesis, then you can say, it's reasonable to think that my suspicion is confirmed. It's reasonable. It's reasonable to believe my suspicion. So, in other words, it's reasonable to think that we have a lithium ion battery that will charge in 2 minutes, exactly 2 minutes. It's reasonable to think that it will take 5.5 hours or less to fly to Los Angeles Airport, LAX, right? It's reasonable to think that it will take five. It's reasonable to think that the price of Home Depot will be $75 or more. Okay. So again, if the test statistic goes past the critical value and goes into the region of rejection, then we will reject our hypothesis. We'll say, no, no, that hypothesis is wrong. Forget it. No way, Jose. Okay. But if our test statistic does not go past the critical value and it lands in the region of non-rejection or the region of acceptance, okay, non-rejection region, then we will fail to reject the null hypothesis. And if it will fail to reject our hypothesis. And if we fail to reject our hypothesis, then we'll say, yeah, it's reasonable to think my suspicion is correct. It's reasonable to think my hunch is, right on. Okay. So again, there's going to be a lot of moving parts and bells and whistles with this. But at the end of the day, a hypothesis test is nothing more than a test statistic versus a critical value. You're trying to figure out if your test statistic lands in the region of rejection or the region of non-rejection. Okay, that's all there is to it. That's all there is to any hypothesis test. Okay. All right. So let's get started now. I'm going to begin by going over the 5 steps that compose any hypothesis test, whether it's a 1-sample hypothesis test, a 2-sample hypothesis test, a 3-sample hypothesis test, a 12-sample hypothesis test. Okay. I'm going to go over the 5 steps. There's only 5 steps to any hypothesis test, and I'm going to go over them right now. Okay. Let's try to make that nicer. Okay. Step number 1, you are going to state the null and alternative hypothesis. Okay. Now, step number 1 might take us a little bit of time. This is a huge one, okay? And it's worth spending some time on it, okay? Because we need to make sure we get this correct. Step number 1, state the null and the alternative hypothesis. Okay. So, the null hypothesis is designated as H sub 0, okay? It's what we are going to try to test. This is our hunch. Okay. H sub 0 is the thing that we care about. It's the important thing. Okay. So let's say that we're doing a 1-sample hypothesis test. Okay. Let's say we want to know if the stock price of Home Depot will be $75 at the end of the day. Okay. So in other words, if we want to know, will the stock price of Home Depot be $75 at the end of the day? Then the way you would write that is we want to know, will the price of Home Depot, will the average, I'm going to try to make mu a little bit better here. Okay. No, I didn't make it better. Will the average at the end of the day be equal to $75? That's what I want to know. I want to know, all right, well, I have a hunch. Is the stock price of Home Depot going to be $75 at the end of the day? I don't know. Let's test it. My null hypothesis, the thing that I want to know, H sub 0, the null hypothesis, will the average be $75? In other words, will it be equal to $75? Okay. Against the alternative, okay, the alternative hypothesis is the thing you are going to believe. The alternative, H sub A, that is what you will believe if you end up rejecting the null hypothesis. So in other words, we do this whole test, we do all these bells and whistles, these moving parts I'm talking about. And let's say we end up getting to the end and we say, you know what? it is not reasonable to think that the stock price will be $75 at the end of the day. Okay. It's going to be 90, whatever. Okay. Well, at the end of the day, if we end up rejecting the null hypothesis, if we end up crossing this out, okay, if we reject the null hypothesis, the alternative is what we are going to believe. Okay. The alternative is what you will believe. So, whatever the null is, not usually, you always have the opposite in the alternative. Okay. So again, step one from the top, state the null and the alternative hypothesis. Well, what I want to know is, will Home Depot be $75 at the end of the day? So if my equal sign is in the null, my alternative hypothesis has a not equal to sign. Okay. Mu not equal to $75. Okay. So that's one way, that's one thing that I could do. We'll call that case A. Okay. There's going to be three cases for step one. There's going to be A, B, and C. Okay. One thing that I might want to do, I might want to know, all right, well, is Home Depot going to be $75 at the end of the day? Another thing that I might want to know is, well, you know what? Maybe it won't be exactly $75. Maybe I want to know at the end of the day, will Home Depot be $75 or more? Okay, so in other words, will Home Depot, will the average be greater than or equal to $75? Okay, will the average be 75 or more? Okay, this is another one that I could have, right? That's another possibility. Okay. Again, so this is my null hypothesis, mu greater than or equal to 75. In the alternative, what you would end up doing is, again, you always put the opposite. You put the alternative always gets the opposite from whatever the null is. So just like here, this is equal to, this is equal, not equal to. So here I have greater than or equal to. Down here, I'm going to put less than. Okay. I am not putting less than or equal to. This down here, this alternate, it does not get less than or equal to. Okay. Just as an aside, right? The nulls, the nulls can get equal to, right? This is equal to, this is greater than or equal to. We'll see over here at case C, we can have less than or equal to, okay? But in the alternative, here we have not equal to. This is less than. We are not going to do less than or equal to. Why not? We do not do less than or equal to because up here we have greater than or equal to. If we put less than or equal to down here in the alternative, then we would have equal to in the null, equal to in the alternative. You would have two equalities in the same test. You can't do that. Okay. In other words, let's say that it turns out the price is $75. If the price actually is $75, right, for case B, we're still focused on case B. Let's say the price turns out to be $75. Well, here, if it was mu greater than or equal to 75, hey, it's 75. This is correct. If we put mu less than or equal to 75, we would say, hey, well, that's correct too. You can't have the null and the alternative both be correct. Right? So again, greater than or equal to against less than 75. Okay. Case C, let's say we want to know, you know what? I don't think IBM is doing so, IBM. I don't think Home Depot stock is doing so great these days. I think it's going to go down. So you know what? I have a feeling that mu, the price of Home Depot stock, will be less than or equal to $75. I think it'll be less than or equal to $75. Sure. Against the alternative, mu greater than $75. Okay. So in other words, I think that the price is headed down. I want to know, is it going to be less than or equal to? And then I just put the opposite in the alternative hypothesis. I do greater than. Okay. These are the three cases that you can have in all hypothesis testing. You have case A, case B, and case C. Okay. You're always going to have equal to, not equal to, or you will have greater than or equal to with a less than, or you will have less than or equal to with a greater than. Okay. That's all there is. Now, I just want to be totally clear, right? This is what we're doing right now is a one sample hypothesis test. Okay. We are trying to figure out the relationship between a stock price and a specific value, right? Remember, the whole point of a one sample hypothesis test is to figure out the relationship between your hunch, your suspicion, your hypothesis, and a specific value, right? Will it take 5.5 hours or less to get to Los Angeles? Will Home Depot stock be exactly $75 at the end of the day? A two sample hypothesis test, the whole point of a two sample hypothesis test is to compare one population against the second population. Okay. So, in other words, does it take longer to fly from Los Angeles? Sorry, excuse me. Does it take longer to fly from Newark to San Francisco or to Los Angeles? Right? What is a longer flight, Los Angeles or San Francisco? Is the per capita income of Jersey City higher than Hoboken's? Okay. Are the Yankees better than the Mets? Okay. The reason I bring that up for a two sample hypothesis test, right? The reason I bring that up is because I want you to see how easy it would be to do a two sample, to incorporate a two sample right here. Okay. As I mentioned, we are currently doing a one sample hypothesis test. We have our population means against specific values, against 75. Okay. But if I just change this 75, if I wanted to know, all right, well, what's going to have a higher price at the end of the day? Home Depot or Lowe's? Then I could just do, let's say I think they're going to be the same at the end of the day, right? Let's say I think that Home Depot and Lowe's are going to have the same stock price at the end of the day. I could just do, all right, is the average of Home Depot equal to the average of Lowe's? Okay. In other words, I could drop out the numbers and I could simply put in another population. Okay. I just wanted to introduce that now. We'll hold off. That's for another lesson, another time. Okay. But I wanted to just point out how easy it is to convert, quote unquote, convert a one sample hypothesis test to a two sample. I would just get rid of these numbers. And instead of $75 for Home Depot, I would just compare it to Lowe's, a second population. Okay. So that's that. Again, if we learn these 5 steps of any hypothesis test, right? The 5 steps to a hypothesis test, we will be A-okay with all hypothesis testing. Okay. Step 1, always state the null and the alternative hypothesis. Okay. So that's true whether it's a 1 or a 2 sample or a 20 sample hypothesis test. We're always going to state the null and the alternative. Okay. Now, I started off this lesson by saying there's going to be a lot of bells and whistles, but at the end of the day, a hypothesis test, whether it's 1 sample, 2 sample, 20 sample, all we're doing is comparing a critical value, a test statistic against a critical value. If the test statistic goes past the critical value, then we end up in the region of rejection, and we would reject the null hypothesis. On the other hand, if the test statistic does not go past the critical value, then we end up in the region of non-rejection, or the safe region, and then we will fail to reject the null hypothesis. Okay. So again, this test statistic critical value thing seems to really matter. Let's see what I'm talking about with the regions of rejection, the regions of non-rejection. Okay. If you have a equal to with a not equal to, okay, specifically if the alternative hypothesis has a not equal to sign in it, that is telling you, let me make this a little bit higher. If you have a not equal to sign in the alternative hypothesis, then you have what is known as a two-tailed test. Okay. You have a two-tailed test. Okay. You have a two-tailed test. 0 is in the middle. I'm going to try to make this a little bit smaller in case I need space. Okay, 0 is in the middle as always. Okay. This tick mark right here and this tick mark right here, those are critical values. This is a positive critical value. And this is a negative critical value. It is negative because it is to the left of 0. This is just a number line. Okay, right here, this is just a number line. So we have negative infinity, positive infinity, negative, positive, okay? So again, this is a negative critical value. This is a positive critical value, okay? Let's just pretend, I'm just making up these numbers, okay? I'm completely making them up. Let's suppose that my critical value is -3. Okay. Where did I get that from? I totally made it up. We don't get the critical value until step 4. And if you look up right here, state the null and alternative hypothesis, we're only at step 1. Okay. We're only at step 1 right now. So where did I get the critical value from? I made it up because we have to wait until step 4 for that. So I'm plucking it out of thin air. But let's pretend we have a critical value of -3. And then we have a positive critical value of +3. Okay, -3, +3 for our critical values. Okay. Remember, at the end of the day, a hypothesis test is nothing more than comparing a test statistic against a critical value. That's all it is. It's a test statistic against a critical value. All right. Let's pretend that my test statistic, let's say that the value of the test statistic, it turns out to be 1. Okay. On a number line, so in other words, my test statistic, my t-stat, let's just say equals, I'll make it 1.5. Let me try to clean that up. That's probably going to get a little messy. Okay. Let's just suppose that my test statistic comes out to be 1.5. On a number line, 1.5, on a number line, 1.5 is in between -3 and +3, right? The test statistic 1.5 is between -3 and +3. that means that I would fall into this non-shaded region. I fall into this white region, okay? Right here, I fall into the middle of the distribution, okay? If I fall into the middle of the distribution, if I'm in the non-shaded region, if I'm in the non-shaded region, then what I will do is I will say I'm in the region of non-rejection. I set it up that way on purpose, right? It's the region of non-rejection, okay? The non-shaded region is the region of non-rejection, okay? So the non-shaded regions. Non-shaded regions are non-rejection. Okay. Here, let me write. Let's do interpreting. Non-shaded regions are non-rejection, which means you fail to reject the null hypothesis. Okay, so in other words, let's just look back down here, bottom left-hand corner, right? If my critical values are -3 and +3, just if they are, okay? If my critical values are -3 and +3, and if my test statistic is 1.5, where did that come from? I'm making it up. But if the test statistic is 1.5, critical values are -3 and +3, that means that I have landed in the region of non-rejection. If I land in the region of non-rejection, then that means I will, if I'm in the, sorry, if I'm in here in this non-shaded region, if I'm in the non-shaded region, then I can non-reject. I'm in the region of non-rejection, so I fail to reject the null hypothesis. Okay, this is the non-rejection region. On the other hand, the shaded regions, okay, this is the region of rejection. And this is a region of rejection. Okay. That's why it's a two-tailed test. Okay. You can see right here where I wrote two-tailed test. Okay. A two-tailed test has two rejection regions. There's one on the left side, there's one on the right side. So the two regions of rejection that come with a two-tailed test comes with two rejection regions. We have a negative critical value and a positive critical value. So those two-tailed tests in the region of rejection, that means if we end up in a rejection region, then we will reject the null hypothesis. Okay. What does that mean for us? Well, okay, let's pretend that I go and I get my critical values and they're -3 and +3. And then I go and I get a test statistic. Let's say my test statistic is -8. Okay. Where did that come from? Just pretend I've got, just pretend. Okay. So if I go and I get my test statistic and it's -8, -8 on a number line, right? -8 is to the left of -3. Right? Same thing goes for +8, right? If I ended up with a test statistic of +8. +8 and -8 are past -3 and +3. Okay. And if you remember what I was saying, right? At the end of the day, a hypothesis test is nothing more than a test statistic versus a critical value. So if your test statistic, if the t-stat goes past the critical values, then you end up in the region of rejection. Okay, this test statistic is in the region of rejection. This test statistic is in the region of rejection. They have gone past the critical values. If you end up in the region of rejection, then you are going to reject the null hypothesis. Okay, so in other words, right here, you would say, oh, wait a minute, hold on a second. My test statistic, that test statistic is in the region of rejection. So therefore, I'm going to reject the null hypothesis. You would basically, cross this out, cross out 75 and say, no, 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 no. You don't, by the way, you don't actually cross it out. But you would say, no, 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 no. I'm crossing out 75. I don't think Home Depot stock is going to end up finishing the day at $75. No way. Not happening. Instead, I believe the alternative hypothesis. The alternative hypothesis, it's much more reasonable to think that IBM stock or Home Depot stock or whatever stock will finish the day not equal to $75. Okay. That's what we're doing with hypothesis testing. Okay, that's how it works. At the end of the day, we are comparing a test statistic, whether it's 1.5, positive 8, or negative 8. We're comparing a test statistic versus a critical value. If the test statistic goes past the critical value, if the test statistic goes past the critical value and lands in the rejection region, right? If you land in the rejection region, then you will end up rejecting the null hypothesis. Okay. On the other hand, if the test statistic does not go past the critical value, right? You have critical values of -3 and +3. If the test statistic, if it's 1.5, or if it's -1.5, or -2, or positive 2.8, or, whatever, right? If it's in here, if your test statistic does not exceed the critical values, then you are in the non-shaded region. And if you're in the non-shaded region, then you are in the region of non-rejection. If you're in the region of non-rejection, then you will fail to reject the null hypothesis. Okay? You will fail to reject, which means if you fail to reject, you're saying, all right, it's reasonable to believe the null hypothesis. It's reasonable to believe my hunch or my suspicion. Okay? That is, at the end of the day, how hypothesis testing works. Okay, this is type A or case A of step 1. If we understand that, the rest of this is kind of, fairly straightforward. Okay, let's do case B. Case B only has one region of rejection. Okay, 0 is back in the middle here. Okay. And case B only has one region of rejection, and it's over here. Okay. It has a negative critical value. Negative critical value, and we call this a one-tailed left-tailed test. Why do we call it that? Because there's only one tail. There's only one region of rejection. That's why it's a one-tailed test. Okay, one-tailed, left-tailed. We only have one region of rejection, and it's over here on the left-hand side. How do we know if it's on the left or the right? Look at the alternative hypothesis. The alternative hypothesis is pointing left. Since the alternative hypothesis is pointing to the left, right? The less than sign here points left. That's telling us we have a one-tailed, left-tailed test. Okay. So put it all together. Type A, right? In case A, we have a not equal to sign. That gives us a two-tailed test. Okay. Whenever you have a not equal to, you know you have a two-tailed test. You have a left tail and a right tail. You have a negative critical value and a positive critical value. For case B, anytime you have a less than sign, whenever you have a less than sign in the alternative hypothesis, a less than sign gives you a one-tailed, left-tailed test. It's over here and it's pointing left. That means you have a negative critical value. Okay. Finally, over here for case C, okay, for case C, we have a one-tailed, right-tailed test. One-tailed, right-tailed test. Okay. We have a one-tailed, right-tailed test with a positive critical value. With a positive critical value. How do we know we have a one-tailed, right-tailed test with a positive critical value? Well, because here in the alternative is pointing to the right, right? It's pointing this way. Since it's pointing to the right, we know that we have a one-tailed, right-tailed test. Okay. So I mentioned that step one is a big one. There's a lot of moving parts involved in this. Okay. Step one, the first step to any hypothesis test is always state the null and the alternative hypothesis. Okay. We have to state the null and the alternative. The null is what we believe. It's our hunch. It's what we're testing. Okay. The alternative is what you will believe if the null turns out to be wrong. Okay. When you do that, we can then make three cases. We could do equal to, not equal to, greater than or equal to, less than or equal to, greater than. Okay. Those are the three combinations that exist. Okay. The three cases that exist with all hypothesis testing. Okay. That's it. I just want to be clear now. Right now, we're doing one sample hypothesis testing, but we could very easily convert this to a two sample hypothesis test. Okay. Remember, right here for case A, we're saying, look, will the stock price of Home Depot be $75 at the end of the day? Will the stock price of Home Depot be greater than or equal to $75 at the end of the day? Or for case C, will the stock price of Home Depot be less than or equal to $75 at the end of the day? Okay, that's fine, right? That's a one sample hypothesis test, because a one sample hypothesis test, the whole purpose is to compare a population against a specific value. Okay, that's the whole point of a one sample hypothesis test, is to compare it against a specific value. However, in order to do a two sample hypothesis test, all we would be doing is dropping out the numbers, the numerical values, the specific values we're testing, and we could put in a second population. In other words, we would do, is the average income of Jersey City the same as the average income of Hoboken? So we wouldn't have a number there. We would just have, a population. We would have a variable for Hoboken. We could do, is the average of Jersey City greater than or equal to Hoboken? Is the average of Jersey City less than or equal to Hoboken? Okay. My point here is not to confuse you. My point here is merely to show you that if you learn these 5 steps of hypothesis testing, because I wrote up top 5 steps to a hypothesis test. I didn't write 5 steps to a one sample hypothesis test. What I'm trying to point out is if you follow and learn these 5 steps to a hypothesis test, right? Step 1, state the null and the alternative. This is true whether we're doing a 1 sample, a 2 sample, or a 20 sample hypothesis test. Doesn't matter how many samples are in our hypothesis test. Step 1 of any hypothesis test is always state the null and the alternative hypothesis. And then when you state the null and the alternative, you will always have case A or case B or case C. The only difference would be for a 1 sample, you have numbers here. For a 2 sample, you end up having another population here. That's the only difference. Okay. But other than that, everything will be the same when we move on to 2 sample hypothesis tests. Okay. I just wanted to point that out now, sort of get it out of the way, get us thinking about it. But for the rest of this lesson for hypothesis testing, I'm going to focus on 1 sample specifically. Okay, so this is sort of a little break here. I just want you to know I was introducing 1 and 2 sample hypothesis tests here, but now I'm going to be exclusively focusing on 1 sample hypothesis test unless I state otherwise. Okay. So again, the 5 steps are always the same, right? Step 1, state the null and the alternative. Step 2, step 3, step 4, step 5, these are all going to be applicable to 1 or 2 sample hypothesis tests, but my examples are going to be geared towards the 1 sample. When we get to 2 samples, I will use that in our examples. I'll make it more germane for that lesson. Okay. So, step 1, state the null and the alternative. I want to know, is Home Depot stock going to be equal to $75? That gives me an alternative of not equal to $75, which means I have a 2-tailed test, right? If I have a not equal to sign down here, then I have 2-tailed test. 2 tails means I have 2 rejection regions. This one rejection region here, this other region of rejection here. Okay, so I have a 2-tailed test. I have 2 critical values, a negative and a positive critical value, which means I have a 2-tailed test here. Case B, I have a less than sign in the alternative hypothesis, which means I have a 1-tailed, left-tailed test, so pointing left, with a negative critical value. Or I have case C, I have a greater than in my alternative. If I have a greater than in the alternative, then that means I have a 1-tailed, right-tailed test, and I have a positive critical value. Okay? So that's step 1, state the null and the alternative hypothesis. Step 2. Step 2 is a lot faster. Step 2 is determine or choose the level of significance. Okay. The level of significance is denoted by alpha. Okay. So in other words, determine or choose the level of significance. Okay. In other words, we have to figure out what's alpha going to be. Okay. Now, I wrote determine because most of the time alpha is given to you. Okay. Most of the time in problems, tests, if you run this in Excel, most of the time Excel makes the default level of significance 0.05, which is fine. That's the one it should be most of the time. But If you're doing this from scratch, right? If you're starting out on your own and running a hypothesis test out in the real world, you are going to have to choose the level of significance. Okay, so you choose it. You determine, all right, do I want the level of significance to be 0.01, 0.05, or 0.10? Those are the three most common ones. That's what everybody uses. Okay, so you will make the determination. You will say, all right, I want level of significance to be 0.05. I want it to be 0.01. I want it to be 0.1. Okay. That's what you do in step two. You make that determination. Okay. And honestly, this usually takes you, 2 seconds. Just go level of significance, 0.05. Done. Right? Over. Okay. As I mentioned, the most common ones are 0.01, 0.05, or 0.10. Okay. 0.05 is most common. That's the one that I almost always use. Okay. But if, I use the other ones, 0.01 or 0.1. Okay. The 0.05 is by far the most common one that everyone uses. Okay. So what is the level of significance? What is this telling us, right? What is the level of significance? In other words, what does it mean? Okay. Very simply, this is going to be a little wordy, but if you bear with me, it should make sense. Okay. The level of significance, what it refers to, it is the probability of failing to reject a false null hypothesis. Okay. So it's the probability of failing to reject aka accepting okay. Although I am a bit of a stickler on this, just because you fail to reject something does not mean that you accept it. Those are different things. Okay. Which I could talk about maybe in a minute. But the probability of the level of significance is the probability of failing to reject or aka accepting a false null hypothesis. Okay. So what does that mean? All right. Well, let's imagine that you find yourself on a jury. Okay. Let's make this easy. Let's say you're on a murder trial, unfortunately, right? So you're on a murder trial and you're the jury and you have the defendant standing there going like, I didn't do it. I didn't do it. I didn't do it. I didn't kill him. I didn't kill him. I didn't do this, right? But deep down inside, the defendant actually really did do it. Okay. Let's just pretend, right? It's just I'm just trying to explain this simply. Okay. So you're there on the jury and you're listening to this defendant and you're like, all right. Well, this person, this man or woman, whoever it is, right, is saying like they didn't do it. They're really adamant that they did not commit this crime, right? The person, the defendant's like, I didn't do it. I didn't do it. I didn't do it. And then at the end of the day, they're like, oh, I did. I hope they don't figure it out. Okay? So what we're saying here with the level of significance, okay? The level of significance, it's the probability of failing to reject a false null hypothesis. You're on the jury and you're listening to this defendant say, I didn't do it, I didn't do it, I didn't do it, which is wrong. They're lying. They did do it. But you're sitting there going, you know what? I believe this person. They're really adamant. They seem like they didn't do it. And then you end up saying at the end of the day, you go, you know what? Not guilty. Okay, not guilty. I don't think they did it. I didn't think they did it. They didn't do it. Okay. The level of significance is referring to the probability of you making that decision. Okay. That's what the level of significance is referring to. Level of significance is the probability of failing to reject, aka accepting or believing. It's the probability of believing, right? Accepting a false null hypothesis. In other words, the hypothesis that the person's putting forward is like, I didn't do it. I didn't do it. I didn't do it. Right? But that's false. They did it. So they're putting forward this false narrative, this false hypothesis, and you go and accept it. Okay? You accept it or you fail to reject it. You say, you know what? I think this is reasonable. I think it's reasonable to believe that this person did not commit the crime. Okay? The level of significance is referring to that. Okay? It's not referring to you make a boo-boo mistake, something silly, 2 plus 2 equals 5, right? And you get the problem wrong. That's not what it's referring to at all. Okay? This is statistics, right? We're doing quantitative analysis here. And in quantitative analysis, we are trying to make inferences. We're trying to figure out if it's reasonable to believe something about a population based upon a sample. Most of the time, your sample should be indicative of the population. It probably will be, right? You might not be exact, but you'll be close, very close. But sometimes it will be way wrong. Okay. And if it's way wrong, that's what the level of significance is referring to. Okay. The level of significance is referring to out of all the times you do everything correctly, you run the hypothesis. You step one, you state the null and the alternative, and you do it correctly, right? Step two, you determine the level of significance. All right, 0.05, just whatever, right? Step three, you determine your test statistic, which we're going to do in a second. Step four, you get your critical values, which we're going to do a couple more seconds after that. Step five, you actually run the hypothesis test. You do everything. You get your test statistic. You get your critical values. You compare the two. You find out, oh, okay, I'm in the region of rejection. And there, oh, sorry, excuse me. You say, I'm in the region of non-rejection. Therefore, I fail to reject a null hypothesis. I fail to reject this null hypothesis. And I believe it. You know what? I think that the stock price of IBM will be $75 at the end of the day. I believe that. And then it turns out, nope, you're wrong. You made a mistake. You didn't do anything incorrectly. It's just the nature of statistics that sometimes your sample may not be representative of the entire population. Okay? Think about it like this. If you went to Flushing, Queens, and asked everybody who's their favorite baseball team, you would probably get, I don't know, 90% of that town telling you, the Mets. We like the Mets. The Mets are the best. So then does that mean the Mets are the most popular baseball team in all of New York City? Of course not. The Yankees are. The Yankees, I'm a Mets fan, but the Yankees run New York, okay, for the most part. And that is an example of how you could end up failing to reject a false null hypothesis, or how statistics and sample statistics are not always representative of populations and their parameters. Okay. The level of significance is referring to out of all the times that you run a hypothesis test. Okay. Out of all the times that you do this, what is the probability of failing to reject a false null hypothesis? In other words, the thing that you believe, your hunch, right? Your null hypothesis, turns out it's really wrong, right? Your hunch is not correct. I think the Mets are the most popular team in New York. I think this is the case. Well, it's not really the case, right? I think that the stock price of Home Depot is going to be $75. I really think so. It's not the case. But you run this whole hypothesis test. You do everything correctly. You don't say 2 plus 2 is 5. You say 2 plus 2 is 4, right? You do everything correctly. And it turns out you're still wrong. Okay. The probability or the likelihood of that occurring, that's what alpha is. Okay. Alpha, the level of significance, is the probability of failing to reject a false null hypothesis. Okay. That's step 2. You determine or you choose the level of significance. As I mentioned, 0.05, most common one by far. Okay. Let's go on to step 3 now. Okay, step 3. In step 3, we determine the formula for our test statistic. Okay. Now, importantly, this is one of those places that I was alluding to with my disclaimer when I said, hey, just because we ask ourselves the same questions in hypothesis test as in confidence intervals does not mean that we are necessarily doing the same thing. Doesn't mean they're related at all. Okay. What do I mean by that? Okay. You might remember I said, like, just because you ask yourself, is my team winning in hockey? And you ask yourself, is my team winning in basketball? Just because you ask the same thing doesn't mean that hockey and basketball are remotely related. They're not. Okay. So, in order to get to step 3, we're going to ask ourselves a question that you have heard before when we did confidence intervals. But I just want to point out confidence intervals, hypothesis testing, not related. Yes, they ask the same question, two totally different things. Okay. Confidence intervals are looking at a range of values. Hypothesis testing is comparing against a specific value. Okay. So, step 3, determine the formula for the test statistic. The one and only question we ask ourselves when it comes to getting the formula for the test statistic is, do I know the population standard deviation? Okay. Do I know sigma? If the answer is yes, then our test statistic formula, the t-stat, will be equal to x minus mu, x bar minus mu, over sigma divided by the square root of n. Okay, x bar minus mu over sigma divided by the square root of n. That will be the formula for your test statistic. Okay, so remember, what is a hypothesis test? At the end of the day, it's nothing more than comparing a test statistic against a critical value. Okay, that's all it is. Well, here is how we get our test statistic. In order to get your test statistic, you have to calculate it. Where does it come from? You say, do I know the population standard deviation? If the answer is yes, if you do know the population standard deviation, then your test statistic formula is x bar minus mu over sigma divided by the square root of n. If the answer is no, then your test statistic, your t-stat, will be x bar minus mu over s divided by the square root of n. Okay. So those are the two formulas for getting our test statistic. Okay. Our test statistic formulas, we say, do I know the population standard deviation? If the answer is yes, then we're going to do x bar minus mu over sigma divided by the square root of n. If the answer is no, then this will be our formula. Okay, x bar minus mu over s divided by the square root of n. I just want to be clear here. It's important to notice we are not calculating the test statistic yet. We're not doing it. We are only determining the formula for it. This step should take us half a second, if that. Okay? So in other words, all we're saying is, all right, what am I going to use? What's my formula for my test statistic? Do I know the population standard deviation? Yep, I do. Oh, okay. Well, then this is my formula. Or you say, all right, time to get my test statistic formula out. Do I know the population standard deviation? No. Oh, okay. Well, this is my formula. Okay. But between steps 2 and 3, they should take you like 3 seconds, right? Because you just say, level of significance. What do I want the level of significance to be? Oh, I want it to be 0.01. Okay. And then my test statistic formula. What's my test statistic? Do I know the population standard deviation? No. Oh, okay. This is my formula. Okay. Quick as that, right? That's steps 2 and 3. You don't have to. You could go much slower, but I'm just trying to point out that you don't have to spend a lot of time on it, right? You just do level of significance. 0.05. That's the most common one. That's the benchmark. That's the great one, right? 0.05. That's 5%. That's 19 out of 20, right? 5%. Well, 5% is 1 out of 20, right? So then you say, all right, that's good. Let's go. Okay. So test, and then step 3. What's the formula for our test statistic? Do I know the population standard deviation? If the answer is yes, then we're going to work with this formula. And if the answer is no, then we're going to work with this formula. Okay. So that's step 3. Step 4 is determine your critical values. Okay. And in order to determine our critical values, we need 3 things. Okay. Well, actually, you need 4 things because you need the ZT and F distribution. So you might want to have that handy. Okay. But then in order to get the critical values, we need 3 things. We need to know, do we have a 1 or a 2-tailed test? Okay, we need to know if we have a 1 or a 2-tailed test. We need to know the degrees of freedom. Degrees of freedom is n minus k, right? N is the number of observations. K is the number of samples. Okay. N is the number of observations. K is the number of samples. Currently, we are doing 1 sample hypothesis testing. So since we are doing 1 sample hypothesis testing, that means that we are doing n minus 1, right? N, number of observations. So however many observation, let's say you look at, you look at 6 different stock prices. That means that you have 6 observations. K is the number of samples. We are doing 1 sample hypothesis tests. So you would do 6 minus 1, 5 degrees of freedom. That would give you 5 degrees of freedom. So we need to know, to get the critical values, we need to know if it's 1 or a 2-tailed test. We need degrees of freedom, which is n minus k. And then we also need to know alpha. Alpha equals what? which you choose, right? So you need to know if alpha is 0 0.01, 0 0.05, or 0.10, okay? But step 4, determine the critical values. So if we have those 3 pieces of information, if we know that it is a 1 or a 2-tailed test, we know what our degrees of freedom are, and if we know what the level of significance is, then when you go to get your critical values, we go over to the Z, T, and F distribution, which is what I'm going to share right now with us. Okay. Okay. So we have the Z, T, and F distribution. In order to get the level of significance, in order to get the critical values, we are going to go down to pages 2 and 3. Right now I'm on page 1, area under the normal curve. We don't need that, okay? Instead, we go down to the T distribution. The critical values always come from the T distribution, okay? So we go down to pages 2 and 3 of our PDF. And we might notice here on page 2, right, it says confidence interval. And then underneath confidence interval says 80%, 90%, 95, 98, 99%. Okay. And then it says level of significance for one-tailed test. A level of significance for a one-tailed test, and it says 0 0.10, 0 0.05, 0 0.025, which skip, okay, and 0 0.10. Then we already know that down the rows on the left-hand side of the page, we have degrees of freedom. Goes 1 to 35. And then it picks up again over here on the right-hand side, degrees of freedom 36 to 70. Okay. And then on the third page of the PDF, the second page of the T distribution, then we have 71 to infinity for degrees of freedom. Okay. So I'm just going to start making this up, right? Let's try to calculate or discover some critical values. I'm just going to make up some examples and we're going to locate it in the table, okay? Let's say that I have a one-tailed test with 12 degrees of freedom at the 0 0.05 level of significance. Okay, so I have a one-tailed test, 0.05, 12 degrees of freedom. Okay, I would go one-tailed test, right? One-tailed test, 0.05, level of significance 0.05, one-tailed test. Then I would go to 12 degrees of freedom, right? 12 degrees of freedom down the left-hand side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 degrees of freedom. And then I have one-tailed test, 0.05. Just match these up. My critical value would be 1.782. Okay, 1.782. Now, you might remember, if we have a left-tailed test, right, a one-tailed left-tailed test, you would have to make that number negative. Okay, just keep in mind, right, that's case B, right? Case B of step 1, a one-tailed left-tailed test. If we have a one-tailed left-tailed test, then that means you have to just add a negative onto 1.782. Okay, just wanted to point that out. But level of significance, one-tailed test, 0.05, 12 degrees of freedom, 1.782. All right. What about 45 degrees of freedom, two-tailed test, 0.01 level of significance? Okay, well, if we have a two-tailed test, right, level of significance, two-tailed test, 0.01 for the level of significance, right? So two-tailed test, 0.01, 45 degrees of freedom, right? 45 degrees of freedom, two-tailed test, 0.01, 2.69. Okay, 2.69 is our critical value. Okay, and then since this is a two-tailed test, right, 45 degrees of freedom, two-tailed test, we would have plus minus 2.69. Okay, 2.69 would be plus minus because we have a two-tailed test. Okay. What about if we had a level of significance of 0.10 for a one-tailed test? Right, level of significance for a one-tailed test, 0.1, right? If we did a 0.1 level of significance for a one-tailed test with 53 degrees of freedom, right? One-tailed test, 0.1, 53 degrees of freedom, right? 53 degrees of freedom. Level of significance for 0.1, 0.1, one-tailed, 0.1, 53 degrees of freedom, 1.298. That would be our critical value. And again, if we had a one-tailed left-tailed test, if we had a left-tailed, we would have to make this negative, negative 1.298. And then finally, if we had 120 degrees of freedom with a two-tailed test, 0.05 level of significance. Well, if we had 0.05 level of significance, see if I can fit this in here. Okay. If we had the level of significance, two-tailed test, level of significance 0.05, 0.05, two-tailed level of significance 0.05, we go down to 120 degrees of freedom, right? 1.98. So 1.98 would be our critical value. It would be plus and minus 1.98 because we have a two-tailed test. So you would have a negative critical value and a positive critical value. Okay, so 1.98. Okay, so that's step 4, how we get our critical values, right? We determine the critical values there in step 4. You need 3 things to do it. You need the level of significance, whether it's a one or a two-tailed test, and the degrees of freedom. Okay, those 3 things you put together, and then you have your critical values. Remember, if you have a one-tailed, left-tailed test, you have to make the critical value negative. You just have to add a negative onto the number that comes out of the t-distribution. Okay. Finally, so that's a 4 steps. There's 5 steps to a hypothesis test, but we've gotten through 4 so far. Step 1, state the null and the alternative, right? When you state the null and the alternative, you can either have an equal to, not equal to, which is a two-tailed test. You can have a greater than or equal to with a less than sign. That would be a one-tailed, left-tailed test. Or you can have a less than or equal to in the null with a greater than sign in the alternative. Okay. And that ends up giving you, right? That would give you a one-tailed, right-tailed test. Okay. So those are the 3 options that you get when it comes to step 1, state the null and the alternative hypothesis. And you can apply that for whether it's a specific numerical value, as you would do with a one sample hypothesis test, right? If it's a specific numerical value, then you're comparing it. If it's a one sample hypothesis test, you're comparing against a specific numerical value. If it's a 2 sample hypothesis test, then you're just replacing that numerical value with a second population. Okay. But again, state the null and the alternative. All right, equal to, not equal to, less than or equal to with a greater than, or greater than or equal to with a less than sign. And that gives us all the different cases, case A, B, and C of step 1. Okay. Step 2, level of significance, right? I mentioned that it's going to be 0.01, 0.05, or 0.10. Those are the 3 levels of significance. That's all it can be. Step 3, determine the formula for your test statistic, right? Determine the formula for your test statistic. What we do there is we ask ourselves, do I know the population standard deviation? Okay, if the answer is yes, then you're going to work with one formula. It'll be on the left-hand side of our diagram. And if the answer is no, then we're going to work with a different formula. Okay. Finally, step 4, critical values. You have to determine your critical values. In order to get the critical values, we need 3 different things. We need the level of significance, the degrees of freedom, and whether it's one or two-tailed. Okay? And that's all we need to get the critical values. Now, once we do that, step 1, null in the alternative hypothesis. Step 2, level of significance. Step 3, determine the test statistics. Step 4, get the critical values. At the end of the day, we finally get to do step 5, which is the actual hypothesis test, which involves calculating the test statistic, comparing it to the critical value, and then after that, we get to determine whether the test statistic falls into the region of acceptance or the region of non-rejection, or falls into the region of rejection, right? Does the test statistic go past the critical value? Does it go past the critical value and into the region of rejection? Or does it stay close to the center? It stays in the region of non-rejection, which means that we fail to reject the null hypothesis, right? If we fail to reject the null hypothesis, then, if the test statistic falls into the region of non-rejection, then we fail to reject the null hypothesis. And if we fail to reject the null hypothesis, then it's reasonable to believe whatever it is we're trying to figure out, right? Then we say, yeah, okay, I think the stock price is going to be $75, right? I think that it will take 5.5 hours or less to get to Los Angeles, okay? If we fail to reject the null hypothesis, then we say, like, yeah, it's reasonable to think whatever it is I care about. But if we compare the test statistic against the critical value, okay, if we compare the test statistic against the critical value, and we find out that the test statistic goes past the critical value, if it actually goes past the critical value, then what ends up happening is we're in the region of rejection. And if we're in the region of rejection, then we end up rejecting the null hypothesis. We say, you know what? No way. Nope. I don't think that the null hypothesis is reasonable to believe, right? I reject that hypothesis. I don't think it's reasonable to believe, and therefore I'm rejecting it. And if I reject my null hypothesis, if I reject the null, then what I'm saying is it's not reasonable to think that the stock price of Home Depot will be $75 or more. Or it's not reasonable to think that the flight will get to Los Angeles in 5.5 hours or less. Okay? Nope. You say it's unreasonable to think that. Okay? So, step 1, null in the alternative. Step 2, level of significance. Step 3, determine the critical value. Step 3, determine the formula for the test statistic. Step 4, determine the critical value. Step 5, go, right? Do the hypothesis test. It's time to actually go, right? I'll write it out here for us because we're going to do one when we start doing examples, right? Step 5 is going to say, step 5 will say, perform the actual hypothesis test. Okay. So in other words, right, steps 1 through 4 are really just the setup, right? Step one is like, this is my hunch, right? Step two, level of significance. It's, oh, well, this is the probability of making, doing everything correctly, but still ended up, being wrong, right? Step three, determine the formula for the test statistic. Okay, it takes us 2 seconds. Do I know the population standard deviation? All right, good. Step four, determine the critical values. Okay, well, it's one-tailed test, degrees of freedom, level of significance, boom, then we're done, right? Okay. Step five. Step five is when you actually perform the hypothesis test. That's when you calculate the critical values. Calculate the test statistic, compare to the critical values, and conclude. Okay. That's when you actually perform the hypothesis test. Okay. Now, related to that, which we're going to do some examples. Okay. But related to this is something known as a p-value. Okay. A p-value. A p-value is some extra information that you can get from a hypothesis test. A p-value is almost step 5B, where if you want to think about it as step 6, you can. Okay. When we do p-values, let's say you decide, you know what, I fail to reject the null hypothesis. I fail to reject it. I don't believe. I fail to reject the null hypothesis. I believe that my hypothesis is reasonable. Okay. I think it's reasonable to think that the price of Home Depot stock will be $75 at the end of the day. Okay. A p-value is telling you how confident you can be in your decision. Okay. So, in other words, what a p-value is doing is, again, let's go back to the jury analogy, right? Let's say you say, you know what, this person's up for committing a crime, right? They're up for committing a murder. Should they spend the rest of their life in prison? You're like, man, I don't know. I mean, I think they're guilty. I think the person did it, but like I really just don't know. I don't know if I'm comfortable sending somebody to jail for the rest of their life uh, based upon like what I think is reasonable or unreasonable. Okay. The p-value would be like finding, the weapon or a confession or something, right? The p-value is that extra oomph you need to say to yourself, oh, wait, okay, you know what? Now I'm more confident. Now I believe that that person did commit the crime or didn't commit the crime, right? Maybe you find somebody else who's admits it and guilty. You're like, oh wow, we had the wrong person there. Okay. So that is step 5B. Okay. I like to think of it as step 5B. Some other people, some other individuals like to think of it as step 6. It doesn't really matter. Okay. But step 5B is calculate the p-values. Okay. So that's what's coming up next. Okay. In our next lesson, we are going to do some examples of hypothesis tests. We're going to do a couple hypothesis tests, actually work through it and see the different mechanisms that we do in order to solve hypothesis tests, right? We're going to do steps 1 through 5. And then at the end, we're going to calculate p-values. We're going to talk about how to get the p-value and then discuss how to interpret that, which will give us additional information about how confident we can be in our decision making. Okay. So we're going to pick it up again and start doing some examples of one sample hypothesis testing.